Let's take a look at some systems of equations and see if we can't classify them into some definitions. Let's look at 5x plus 4y being equal to 2, and we will also look at 2x minus 8y and say that that's equal to 4. Well, to solve this system of inequalities, it looks like the easiest thing we can do is multiply the top one by 2. That way we can eliminate the y's here. So if I multiply everything here by 2, that becomes 10x plus 8y, and that's now equal to 4, multiplying everything by 2. Then we can just combine them straight down. I'll have 12x, the 8y's cancel, is equal to 4 plus 4 is 8. And so I can then divide both sides by 12. So x is equal to 2/3. 2/3. And with that we can use to substitute, let's see, 2 times 2/3 minus 8y is equal to 4. So 4/3, 8y is equal to 4. Get rid of that by multiplying everything by 3. 4 minus 24y is equal to 12. Negative 24y is equal to minus 4, 8. Divide both sides by 24y, 24. Boom, y is equal to 8 over negative 24 is a negative 2. No, negative 1/3. Negative 1/3. So this system has the solution 2/3, negative 1/3. Now, because it has a solution, we are going to say that this is a consistent system. And because both of these lines, were to graph them, they'd be two different lines, then we would say that this is an independent system. So consistent and independent means that it has one solution with two different lines. And that kind of stands to reason, right? If it has one solution, it can only have two different lines. So let's take a look now at a different system of equations. Here we have two equations, 2x minus 4y is equal to 5 and 2x minus 4y is equal to 6. So in order to eliminate, we will multiply everything by a negative 1, and we'll basically just change the signs, right? Negative 2x plus 4y is equal to negative 6, and then combine straight down. So those cancel and those cancel. That leaves me with 0 is equal to 5 minus 6 is negative 1. Well, look at that. That is not good. That is not a very good solution because 0 does not in fact equal negative 1. So what we say about this system of equations, because it gives us a contradiction, we say that this system is inconsistent. It is inconsistent, and because they are different lines still, it is independent. So inconsistent and independent means no solution, parallel lines. By definition, parallel lines are different lines. And finally, let's take a look at a system of equations. Again, we can use elimination here to see what we have. If I multiply this by a negative 2, take this whole thing, multiply it by a negative 2, I will get negative 4x. That gives us minus 6y, and that will give us minus 2. So if I add those together, negative 4x plus 4x is 0. Well, cancel, those cancel, and those, everything cancels. I've got 0 is equal to 0. Well, the thing about 0 being equal to 0 is that's always true. That's what's called a tautology, something that's true just because of the way we say it. And because it's always true, we know that this system is consistent in that it consists of a solution. In fact, it consists of all solutions, or infinite solutions. Whatever fits one equation will fit the other. Infinite solutions. Whatever fits one equation will fit the other equation. So it is consistent, but because they are the same line, if I were to graph this on a coordinate plane and graph the other line on a coordinate plane, they would be the same line. That means that they are dependent. So a system that is consistent and dependent are the same lines and share infinitely many solutions.